Hi, my name's William Malik. I'm Vice President for Infrastructure Strategies with Trend Micro. We're going to spend the next few minutes talking about supply chain cyber risk, what it is, where it comes from, and how to manage it, and how to deal with the impact of a problem should it occur in your environment. So let me begin by bringing up a few slides. Feel free to share these if it is helpful in your work. So, supply chain cyber risk comes about because we rely on models to understand our environment, and these models are of necessity incomplete. This is the DevSecOps software development model. May have seen this before. Stuff goes from the planning phase, develop some code, you assemble it into a set of modules, you then test those, put them into production, and so on. This model shows you how it should work. It shows you the flow of the key output of this process, which is the running application in a production environment and how it ties in. What the model does not show is the extensive set of third-party dependencies, various supply chains that make this possible. So here we add a few of them. Developers are smart. They're engineers. They do not want to waste time on solving problems that have already been fixed. And so when it comes to writing code, they will make use of code that their colleagues have already written. Sometimes they'll be sharing code within their organization. Often they'll make use of GitHub to get code that's been developed by other practitioners from a shared public repository. They'll use third-party applications, which they'll buy and then interface with via application programming interfaces, APIs, to make use of in their environment. And it doesn't stop there. They go through methods and procedures to maintain their source code. These library control systems, again, are not built ad hoc within each company. There are both open source and purchased products that allow you to manage source code, just as there are open source tools and purchased products to allow you to manage the testing process. What bugs have been found, what patches need to be applied, where are they, have they been through testing, and so on. And when it comes to getting into production, there are versioning systems that will make sure that the release is as expected, that it's deployed as a proven package. The environment in which it runs, whether it's a particular cloud service or a VMware, say, set of virtual machines, that's controlled. Those containers don't come out of nowhere. There's something that you bring from another environment. And while it's running, you use automated operations tools and systems management tools generally to make sure everything is going swimmingly. Now, the problem is that all of these things have external dependencies. And here are some of the issues that have shown up in the way of attacks on supply chain over the past few years. In the production environment, we have Hive ransomware, which goes after ESXi, the VMware environment. The SolarWinds Orion attack and the Kaseya attack involved corrupting the supply chain for systems management tools. Nessus is a network security tool, which can be used as an attack vector. Ripple 20 refers to a set of vulnerabilities in some TCP/IP stacks that have been around for a decade or more. And of course, Log4j is a piece of open source code that was incorporated in a lot of products. And then it turns out that it had a bug in it. So where are we with regard to open source? Well, recently, SNCC, working with the Linux Foundation, published a report, their open source security state report. And this is one of the charts from that. Now, the way to look at this chart is if you answered yes to the question, do you have an open source security policy? Then you want to look at the green bars on the left in each column. If you answered no, you do not have an open source security policy in place, then you want to look at the yellow bars. If you want to see what the overall answer is, then the blue bars on the right will tell you what it is. But with one exception, the fact is that open source security is not in very good shape. When it comes to direct dependencies, around a third, I'm looking at the second set of bars, around a third of the users have some level of trust that they're doing well with the stuff that's out there. But when it comes to indirect dependencies, meaning you're using code from somebody, but they're using code from somebody else and you don't know who they are, well, then that's problematic. The leftmost bar, we don't have good controls, shows a striking difference between those who believe they have good policies in place. About a third say that they don't think they have good controls and they're worried about it. Nearly half of those that don't have a policy in place are worried about the fact that their controls are inadequate. So the point of this, and I recommend you to get a copy of this survey, it was just published a couple of weeks ago, addressing cybersecurity, cyberspace challenges, and open source software. Very good report, very useful. Lots of information, 20-some pages of material. So what do you do about it? Two things. First, I want you to understand your IT environment. You need to know what you've got in your environment. Now, procurement has some of that for the stuff that you've purchased. Your software developers know where they've borrowed the shared stuff that came from open source. You need to consolidate that. You need to put together a comprehensive software asset management database so you know everything that's out there. Beyond that, I would like you to look at a software bill of materials. This thing tells you what the ingredients are in each of those. Think of it as like, you buy a can of soup and it says, this is Campbell's cream of mushroom soup. And you look at the side and there's a label and it says it contains mushrooms and it contains water and it contains salt and it contains flavorings. That's the software bill of materials. It tells you what's in the thing you bought. And you don't have to make up the format. There are standards about what an SBOM looks like, and there are tools that will make use of one. If you are a developer of software that you pass along, then you should provide an SBOM with it. As a consumer of software, you should require an SBOM from your suppliers, because that way you can map problems to potentially impacted components within your environment. Right now, the CISA has a database called Known Exploited Vulnerabilities, KVE. And if you have an SBOM, you can take a look at this database of known exploited vulnerabilities and say, hey, we've got that. And that we don't have a replay of some of the tragic incidents over the past few years when organizations were aware of a problem and then decided erroneously that they did not have that code. Now, setting up a cyber supply chain risk management program is non-trivial. These are foundations for it. But the key element, and it's defined more extensively at the CISA website, the key element is getting in touch with your suppliers and your downstream users and consumers so that you collectively will be able to alert each other and respond as a group when there are breaches, when there are attacks, when there are threats. So that's one of the two things you can do. The other thing you can do is prepare your communication plan. You don't want to look like you're baffled and confused and out of control on MSNBC. You want to be ready. You want to assign responsibilities for tracking down problems, doing the triage, understanding the scope of impact, know who is going to take care of what, and know who outside your organization is going to care if things go bad. This is similar to what you've probably already done for your continuity of operations. Who cares if the organization isn't working? Well, your customers, your employees, your suppliers, your investors maybe, regulatory agencies maybe. Get that list together. It's not a long list. And ask yourself, what kind of questions would they likely have if you are a victim of a supply chain attack? And then make sure you've got those relationships in place and test the plan. Train for it. There are organizations that will help you do this. And by the way, test the plan every year because your world changes. Make sure you're on top of it. Make sure you know what components are in the car you're driving. So when a light comes on, you'll be able to understand rapidly what went wrong and what you need to do about it, and how to communicate information effectively without risking any further damage to the organization. I hope that's useful. If you have further questions, please feel free to contact me. Get a copy of these slides from me. I'm William Malik, TM, on Twitter. You can reach me through Trend. And there are some of the resources that I mentioned in the course of this talk. Thank you for your time and attention.